Module 3 examines the engine management module and related sensors, as well as the ignition and charging systems. The engine management module, as its name implies, manages or controls most of the outboard's functions. The EMM uses a software program, known as a map, to control the injection timing, injection duration, ignition timing, ignition duration, and lubrication. This map is adjusted or corrected based on the inputs from various internal and external sensors. Internal sensors track system voltages, EMM temperature, and barometric pressure. The EMM temperature is monitored to protect it from damage. Barometric pressure is used to compensate for altitude. At high altitudes, barometric pressure is low and less oxygen is present, so the EMM reduces the amount of fuel to maintain the correct mixture. The EMM also monitors exhaust back pressure on V4 and V6 models to compensate for engine loads. The EMM has LEDs that can provide basic diagnostic information. We'll cover this in Module 8. All Etec models 40 horsepower and above have an external capacitor on the 55-volt circuit. This capacitor stays charged for up to 2 minutes after the outboard is shut off. Wait at least 2 minutes before handling the capacitor or any components on the 55-volt system. Etec models feature a low-impedance crankshaft position sensor that minimizes signal interference. It's solidly mounted in the face of the intake manifold, eliminating vibration and the need to adjust its position. This sensor is activated by ribs on the flywheel. Some ribs are evenly spaced and others are staggered. Every time a rib passes by the sensor, it generates an AC voltage signal. This creates a unique pattern that the EMM recognizes, enabling it to quickly determine the crankshaft position. This makes rope starting fast and easy. The throttle position sensor, or TPS, is mounted above the throttle shaft. The throttle linkage moves both the sensor and the throttle shaft. Here's the throttle bore and the throttle plate with the throttle position sensor above it. The TPS is a rotary potentiometer. This means it's a variable resistor that is operated mechanically. It has 3 leads. One lead receives a 5-volt reference voltage from the EMM. This current passes through a resistance material to another lead that completes the circuit to ground. The third lead is connected to a wiper in the potentiometer. This is the lead that supplies the EMM information on the throttle position or angle. Remember, as current flows through resistance, its voltage decreases. When the throttle is closed, the wiper is near the ground, so the voltage signal returned to the EMM is quite low. As the throttle opens, the wiper is moved closer to the source. The current reaching the wiper has gone through less resistance, so the voltage is higher. The EMM automatically calibrates the sensor reading whenever the engine starts and whenever the throttle is returned to idle. Let's see what happens if the operator starts the engine with the throttle partly open. Every time the outboard starts, the reading is assumed to be idle or throttle closed. If a lower reading occurs, that new reading is assumed to be idle. If the TPS is disconnected, the outboard will start, but it will only run at idle. If the throttle is open too far when you start the engine, the outboard will only run at idle. The air temperature sensor is located in the throttle body or air silencer. It is a negative temperature coefficient thermistor. This means it's a variable resistor, and as temperature increases, resistance decreases, and vice versa. The EMM uses a 5-volt reference signal. This signal flows through the sensor to ground. The EMM measures the voltage at a point between a resistor inside the EMM and the sensor. As the temperature rises and the resistance decreases, more current flows to ground. This decreases the voltage on the signal lead. The EMM equates the voltage with a temperature value. As the voltage decreases, the EMM knows the temperature is increasing. If the voltage is so low, it indicates a very high temperature. Code 49, air temperature above expected range, will be set. If the voltage is high, indicating an extremely cold temperature, code 48, air temperature below expected range, will be set. If the sensor is unplugged or the lead is broken, the voltage will rise to 5 volts, setting code 47, air temperature circuit malfunction. If the lead is grounded, it will pull the voltage down to 0. This will also set code 47. If you disconnect the sensor and check the voltage between the signal lead and ground, you will find only about 2.7 volts. This is because of circuitry inside the EMM. The water temperature sensor works the same way as the air temperature sensor. Again, we have the normal range. When the voltage reading indicates a temperature high enough to damage the power head, the EMM activates SAFE, Speed Adjusting Failsafe Electronics, and stores code 43. SAFE limits the engine to 1200 RPM, which allows the operator to return to port at reduced speed. If the voltage continues to drop, indicating a temperature where the engine will soon fail, it will stop the engine. The outboard can be restarted as soon as it is cooled enough to run in the safe or normal modes. If the voltage goes very close to 0 or 5 volts, the sensor circuit malfunction, code 41, will be set. This will not activate SAFE. V models have 2 water temperature sensors, one in each cylinder head. The starboard sensor has different code numbers from the port sensor and inline models. Whenever you service a water temperature sensor, be sure to use heat sink compound, often called thermal joint compound. For more information, refer to Service Bulletin 2008-01S. A PDF of this bulletin is included on this DVD.